So I've been a simulation modeler for many, many years, and what you do when you model is you run it many times and you have tons of data and you don't know what to do with it. So the key is you have a lot of really interesting information that you want to pass on to either managers or policymakers, but you don't necessarily know how to do that. Communication is difficult. That's why we have sessions like this one. So I just want to show you my team. It's a bunch of modelers. So Barry Baker in Colorado, Alex Seifert in San Diego. Ken and Tim are here, and Tim is actually just gave a talk next door about the model results. And we all work for Conservation Biology Institute. And we ran our model, which is a complicated dynamic global vegetation model that simulates potential vegetation, which for a manager doesn't mean anything. And then we go into carbon, water, and nutrient cycling, and we transform that at different scales, which is complicated again for a manager who's trying to find what their forest in particular has in terms of carbon sequestration potential. And then we run a dynamic fire model that tells you when you should have a fire given future climate and what kind of impacts you will have. And we write papers, we write books, and it's like, and we go to Congress and we make talks over there, try to convince our elected officials that they should do something. And 25 years later, we are still very frustrated. And so we're trying to figure out a way to explain to people what our model results mean. So it's a tall task, and we've been trying many, many ways to do this. We've done workshops, we've tried to get managers to talk to us, and we actually, my team, recruited Mike Goff, who's a web developer. He's a GIS analyst, but worked with us and ended up putting together some websites, particularly for the Forest Service, and trying to manage the data and summarize it for a particular region, be them ecoregion or particular forest. So these two websites were made actually for 3 national forests, Mount Hood, Willamette, and Siuslaw. And so we talked to all these people, and they were really having a hard time understanding what we were trying to produce. And the result of these workshops and these papers and these reports was, okay, do you have anything else that we can actually understand? And so we, in Conservation Biology Institute, has a really cool software development team, and these are the 4 individuals that lead the team. And their claim to fame is databasin.org. If you've never been there, it's free. You can make your own account. You can do GIS online. It's a huge resource. Spatial data sets, I forgot how many we have right now, but it's over 15,000 data sets. The head of CBI, Conservation Biology Institute, had in his head that if people started having their hands on the data, they would start understand better all the conservation issues. So it's like how to make people actually play with the data. It was not a game, it was actually looking at the data, commenting on them, and things like that. And so as a modeler, it was like, okay, there's an idea, we could use this. So we started putting some data sets. Now, of course, there are all sorts of challenges I'm not going to talk about. Our models produce huge data files within a particular format, NetCDF, which is another of these acronyms that doesn't mean anything. That creates problems left and right. And so we had to work with the software engineers saying, yes, NetCDF exists, and you need to build something so you can read it. Anyway, for us, it's great. We upload our data sets into databasin.org. We compare. This is just a view of what the screen looks like. We have a slider. I should do it live, but I'll do that at the Tools Cafe tonight. You can move the slider, and what I've done is list a bunch of model results, and I'm comparing with and without land use in terms of fire. So for me, it's easier to share that with other modelers, with people who are interested in our work. We can also find problems in the model. Sometimes we forget to put land use. We compare our data sets. We're like, there's no difference. So very useful for many, many reasons. But it's still, we can run a movie, so that's useful too, but it's still pretty complex to explain what the model did to get there. So we put the results into galleries, which are just a collection of all the maps of all the results. We cookie cut them for particular geographies that are of interest to some of our clients. This is the California focus one. We cookie cut all our results for the conterminous US just to the state of California. Again, this depends a lot on funding, unfortunately. Doing adaptation and communication is great as long as you can find funding. Sometimes it's not that easy. And then the most important is we do also case studies inside database, and you can write the little stories about your project, about what the model is like. And so really useful to have people being able to read this. Of course, you know that beyond one paragraph, you're not hitting anybody. People in general don't read very much. Everybody tweets. These stories are more than 140 characters, so we lose there. But it's a good entryway into a particular project, and you can click on the galleries or data sets that are associated with a particular project, a particular theme that we've written a story about. Any one of you can do this. If you have a story, if you have data, you can upload your data, you can write your story and put it there. Then you can send the link to anybody and they can have access to it. So we feel it's pretty useful. We've been working extensively with Fish and Wildlife, US Fish and Wildlife, to put gateways together. They are conservation planning atlases is the formal name. It gives the color of a particular geography, and you can go in there, and the first time you search for a data set, it will only look into the geography of your particular LCC. And so it's kind of an easy way, but if you want to search the entire database, then you just click on the search and go for the entire thing. But it kind of helps the stakeholders of a particular LCC to focus on their area. We have 21 public gateways. I think we have, I forgot how many, but over 10 LCCs that have their gateways. You can go online and find out. And they're pretty cool. And every head of LCC has a different way of presenting the data and on adding information to the gateway. In California in particular, we've been working with a group focusing on the Desert Renewable Energy Conservation Plan. And the first thing they did was put a report together, and they wanted to have a tool that would help people to log in and actually do a commenting. So they wanted comments from the experts that they had hired, but they also wanted public comments. So we put together a website where people could actually access the data that were discussed in the report and actually look at it and comment on the map. So that was very useful to them. And then we started putting some specific tools like the covered species database, which shows this. So you have the list of species for a particular area, and it tells you the federal status, the state status, and then what the actions are if you ever do something that needs an EIS, what the rules are about each species, and then the intactness of that particular piece of land you're interested in, and a distribution map of your species. So that was useful because people could see the photo of the species, which seems to be the thing that everybody said was great. The data was one thing, but the photo was more important. But they could have also all the rules associated with each species. And then we put together a survey analyst. So what we did was you could go on the website, identify the area of concern. It would tell you what species are there. And then you could look at different landscape characteristics, the intactness, the conservation value, soil sensitivity, and if there are any physical refugia. We didn't want to talk about climate change yet. We wanted to say, well, if it's in a deep canyon, it probably won't be as hot as somewhere else, so it's a good place. If it's close to a riparian area, or if it's a healthy riparian area, it'll also be probably mitigating hot sun in the desert. And so we started putting together decision supports so that every piece of information would be a spatial data set that you could click on and show. And then we did unions of the kind of logic models. And then eventually you would get a number that would correspond, in this case, terrestrial intactness. But every single criterion you wanted to use to make your decision was actually transparent and easily accessible. Then we started working with some of the energy companies. And instead of looking at their area and saying, this is what you're going to have to deal with, we said, this is going to be interactive. So we would have a bar. What sort of intactness do you want to deal with? You want high, you want low. Conservation value. What are the different criteria that you want to use to put your new wind turbine or solar panels? And so you play with these criteria: terrestrial intactness, conservation, number of species, corridor condition, And then suddenly when you have all this set up and you know how much, for instance, this is for wind, and you determine this is still with the solar megawatts, but anyways, it tells you exactly where those criteria are met on the map. So if you want to cite anything, these are the areas that are most likely to meet the criteria you have chosen. So pretty useful. And again, we used, Fish and Wildlife, USGS, all sorts of data. So everybody was at the table and could actually work with the energy company to actually cite these future things. And then eventually we got into climate change, and we put together this climate console. And in this climate console, you can pick the units that you need, BLM field office, we have watersheds, we have counties, and then you click on them, and it tells you what the value of the average temperature or the average precipitation or the seasonal precipitation. We have a whole suite of variables, and then we show the uncertainty. We show also the blue point on that curve there corresponds to the climate of that particular geography that you picked, and the full extent corresponds to the entire area of the DRCP. So it gives you an idea. And then of course there's more than climate, so we show also the intactness and the refugia and things like that. So suddenly they had yet another tool to look at more than just land use. They could actually look at future climate. Of course there's caveats in this, all the limitation about models and things like that. But what we wanted to know is, are people using this, and is it useful for them to make a decision? And so I was sitting at a conference like this next to a BLM person who was telling me that this is fine, but how do you know if the managers are going to be using this? And so I said, well, give me a little bit of money so I can get an undergrad student, and then we'll start testing them. And so Melanie is an undergrad student at OSU, and she tried to do a survey, got very little response, which is normal if you read the literature. And then she started calling people, calling managers. And if you heard Kathy Delos talk this morning, she said telephone works really well, extremely well. We started by saying, we'll have an hour with you. The average call with Melanie was an hour and a half. The first half was pretty much managers telling her what they do and how that might be affected by climate. And the second half, she walked them through a bunch of data sets that were in database and specific climate-related websites from the USGS, from NOAA, and some of ours, and say, what works for you? And so that works extremely well. She was recommended to other managers, so her circle of influence really increased, which was absolutely wonderful. And one of the things they asked for was short-term forecasts. So we started by putting NOAA climate divisions, and they all told us, no, it's too coarse. And then fortunately we knew John, and John said, I'm downscaling this, so we can use finer scale. So now our challenge is to use what John Abatsoglu is doing in terms of short-term forecast and really transmit the right information, that this is not something they can put a lot of money on. This is weather forecast. It's like if you turn on the radio or the TV and they tell you it's going to rain next weekend, what's your chance of that happening? Last weekend in Oregon, we were told in Corvallis it's going to be pouring. Well, it didn't. And we knew it, and we kind of say, yeah, the models. But to put this on the web and explain that short-term forecasts have a high uncertainty, and they are different from climate projection, that's a huge communication issue. Anyway, we received money after BLM project was over from the Great Basin LCC, and we continued asking more managers from other places in the West. And now the grad student, the undergrad student who's now becoming a grad student, is testing another climate console and putting together a tool to look more at vegetation cover, because they said, it's fine to give us climate. What we want is really impacts. So now we're trying to teach what are impacts model and trying to bring all sorts of different types of models so they have a good idea of what's out there. So CBI doesn't do just sagebrush in California. We do all sorts of things, and we do also coastal area, and we love to work with people with issues and who are interested in sharing information. And so if any of you have good ideas and funding, that helps. But we love to write proposals with people with good ideas and good data so we can share that sort of information widely. Thank you for your attention. Yes.
And if so, how are you getting, was it,
We talk to managers and we say, you want us to show your data? We'd love to do that. Now, the data can be either private or public. And so we can we can make a group within Databasing, and the group members can have access to private data that cannot be released to the entire public to make that particular decision about a
are
job.
you getting this individually from individual managers, or are you getting it systemically, consistently?
We get consistent data sets from the agency, things that are public, and then we talk to managers who have specific issues about their district, and we get their data and make it to their group. We are trying to be as flexible as we can. Yes. Yes.
Have you just, it's come up quite a few times when I've been talking to people about climate change. Do we have any models yet where even if we fixed it to the extent of 26 to 28% reduction, like the law is calling for, how long would it take for all of this? Is there any models yet? Can you carry your present model out to?
Yes, we can. Actually, most of the GCM run for a lot more than 100 years. But in general, they stabilize the CO2 levels because we have no idea 100 years from now what society is going to do in terms of emission. But otherwise, we have climate for many hundreds of years.
So if we did stop doing what we're doing somewhat, we have a model for that one.
Yeah, well, the 2.6 is, the RCP. You've heard about RCPs, which is one of the scenarios. If we stopped all emissions in, 2020, we see that there's a decline in temperature and things like that. But we are committed right now. I mean, the warming is not going to go away even if we stop all emissions today.
Yeah, it will take how many years to replace your model?
Many years, yes.
Hundreds.
Yeah, this century is pretty much done being.
Have animal rights people been emotionally charged about it, just in general? Does their emotions count?
Yeah, and the problem is some of these organizations use animals as an emotional, just like I use a baby picture to never get it.
Yeah, right.
It's a trick of the trade, yeah. But anyway, so it's like a lot of people have been crying about the polar bear. I sympathize, but polar bears became white because we had glaciers, and now they're going back to their roots, and grizzlies were there before polar bears. And so it's like if you know a little bit of history, you know that change has always been part of this planet and will continue to be. And so yes, there are species we really like that are beautiful, and if we talk about viruses and what their lifeline are under climate change, people are a lot less interested. So if we could balance our judgment with that, wildlife would be really good.
I have a question. You touched on uncertainty a little bit. I wonder
Yes.
if you can talk about that more. It's kind of the elephant in the room.
Yes. So one of the things we've been trying to tell managers, well, in California, for example, Southern California, we've told them, okay, yes, the IPCC has over 30 models that you can use to look at future climate. But out of these models, there's only a handful that look at monsoon. If your vegetation and everything else is driven by monsoon, you need to find models that actually simulate monsoon during the 20th century. Doesn't mean that they're doing a good job in the 21st century, but at least they know what a monsoon is. A lot of people look at future climate and say, and you'll hear the climatologists tell you, an ensemble average is much more reliable, much more than if you take each model individually. But for an impacts model, it doesn't make any sense to use an ensemble because time 2 does not have any link to time 1. It's like, it doesn't make any sense logically. You take a model that has a monsoon, one that has no monsoon, you do an average. What is it that you're using exactly? And so we're trying to teach managers that they need to pay attention to that and pick them, it's like David Rupp, for example, has done a good job at picking the 10 best models for the Northwest. And there's papers out that tell you which ones are doing a good job with ENSO, for example. So we're trying to put that into the message saying, okay, there's a lot to unpack here, but there are basic things you need to know. And so the uncertainty, when you look at 20 model average, you have a huge uncertainty. You look at 3 models, you have some models that say monsoon, some that don't have monsoon. So the uncertainty is about as big as you want. But it still should inform you. The uncertainty has never been something that has prevented people from buying insurance against fire, buying insurance against flooding. It's like people are used to uncertainty. It's just a matter of bringing it to the front and saying, okay, it's a model. It's not a crystal ball. And we're giving you more than you have if we don't say anything. So it's, we're trying to bring new indices of uncertainty, but it's really difficult. We're working with managers specifically. They are really like percentage. You know, it's like, what's the percent chance that we'll have twice as many heavy precipitation events in 2020? So we can look at all the models and say, well, on average, this is what the average of all the models say we should have, you know, maybe 15% increase. They like that a lot more than if we tell them precipitation is going to increase by 20% monthly.
What's the name of the gentleman who compiled the list of the 10 top models?
David Rupp, who works with Phil at Oregon State. And we work with Dan Kayan for California. Same thing for the Arizona monsoon.
Last question, I think.
Just real quick.
Yes.
Is it possible you could go back to the slides with the undergrad with all the data sources? Unless grad students themselves have kind of that little article that I'm using.
Yeah. And what do you want to know about this?
Just to get a picture of the
Oh, a picture.
data sources that you used on that slide.
Yeah, sure.
I tried to do it.
Okay. And I'm not a PC person, but
I can help you get it.
okay. This is it. Oh, perfect. Okay. To the full screen. Yeah. But there's OSU made an article about her and the different data site, and her thesis is on the Oregon State University website too. So
For your name is on there, that'll be really helpful.
yeah.
All right.
And I'll be at the Tools Campus if you want more.
Okay, thank you.